The next problem, which is a titration problem. Now, titration problems are relatively simple. We are going to use this in the lab exercise, and you might want to view this before you get started. But basically, a titration, redox titration operates as just a stoichiometry problem, except the equation is a redox equation. So sometimes you're asked to balance them, and sometimes you're given a balanced one. And in this case, you're given a balanced one. We're looking at iron ore, or excuse me, iron, which is from ore, that they're trying to figure out how much they produced. So if you'll notice, it is a redox reaction because this one is 2 plus, this one is 3 plus, manganese here is 8 minus, so it's 7 plus here and 2 plus here. So if we look at it, iron is oxidized and manganese is reduced. Okay, but when you actually go to work it, it's just a simple stoichiometry problem. So what we're trying to do is find the percent iron in the ore. So what we're really trying to do in our first step is to determine the grams of iron. So remember, when you do stoichiometry and concentrations, etc., you're always going to start with the amount present. So we know that we are starting with 0.04530 potassium permanganate. We know that the concentration of potassium permanganate is, this is liters, is 0.0180 moles of potassium permanganate. Now, a couple of y'all will have said, but wait, where'd the potassium come from? Potassium is strictly the counter ion, so we don't really need it if you'll look at it in the problem. So this is per liter. So remember, this is the molarity. So then we look at our equation. We have 1 mole of the permanganate per 5 moles of the iron. Now, in this particular case, we're only wanting to know the grams of iron. And remember, electrons don't weigh much. So we've got 2 plus or 3 plus, it doesn't matter. But basically, 1 mole of iron is 55.8 grams. So we end up with 0.2270 grams, which we're using grams of, this is grams of the iron. If we're percent iron in the ore, we take the grams we generated, 0.2270 grams divided by 1.225 grams times 100. So that tells us we have 18.59% of iron in this ore. So again, this is a simple way to find out how much is there using a redox. Now, the other beauty of this is manganese is purple. And my class did a kinetics experiment with this. And when it goes to the Mn2 plus, this is yellow to colorless. It depends upon how long you let it go. So when you do the titration, the permanganate acts as both the oxidizer and the indicator. So it's a very simple reaction, and we're going to use a similar reaction to determine the chlorine content in water in the redox lab. So thank you all for listening. Whoops.